Hello and welcome to this video, Asynchronous, Serial and Parallel. This section of the course focuses on the performance aspects of Ansible and how we can improve performance through some of the features built into Ansible. We'll explore playbook performance and bottlenecks. We'll take a look at polling, asynchronous job identifiers, asynchronous status handling, serial execution, batch execution, and alternative execution strategies. To fully understand some of the performance improvements we can achieve in Ansible, we also need to look at the pitfalls, and this therefore means we have to show areas that are inefficient or don't work so well. Stick with me in this module because as we progress, we'll address the pitfalls that we highlight, and you'll truly see how to maximize performance in Ansible. We're in revision 1, and in this folder, if you have a look, we have a playbook here called slow_playbook. In this example, we're using the command module and we're running sleep, which will wait for the time given. In this case, 5 seconds. Before we run this, how long do you think this playbook will take to execute? With some simple maths, we would say just over 30 seconds, given overhead and the collection of facts. Let's try this out. Two things to notice here. We seem to be completing 5 hosts, then we are waiting for the 6, and only then do we continue. At the moment, the Ansible strategy is linear. We're waiting for the task to execute and to finish on all corresponding hosts before we move on to the next task. If we had a task for a specific host, it would hold up the rest of the tasks. I sped up the last bit there just to save you a bit of time. We can see that the total there was 1 minute and 16 seconds, give or take. Let's have a look in revision 2 at how we can improve this. We've changed it here, so in essence, it's only ever going to run against one host, and therefore the others shouldn't hold this up. Let's give this a try. Okay, again, I've sped this one up so you're not waiting too long whilst watching this lecture, and you can see that this one took 41 seconds. A lot more respectable, but again, let's see how we can improve this further. Go into revision 3. Ansible has support for asynchronous task execution, which is useful for long-running tasks where you don't want SSH connections to stay open, or the task to exceed the SSH timeout. Essentially, we can run the task and then we can poll later on for the status. The async value is set to 10, meaning wait at least 10 seconds, and poll is set to 1. So it will poll for the status every 1 second. Let's see what happens when we run this. Okay, as you can see there, we're seeing the same behavior that we saw previously, where it's executing for the 5 tasks, but then it's holding on the last one. At the end, I sped that up for the purposes of the video. Step into revision 4. And in this example, we've set the poll value to 0, which essentially means fire and forget. We're also going to change one of the tasks so that it takes longer than the others, where it's set at 30 seconds. Let's run this for the whole execution, and when we do this, let's run it with the time statement. Okay, so we can see there that that took 12 seconds. So the whole execution took less than 30 seconds. Based on this, we know that the task in question, where we actually had to sleep for 30 seconds, couldn't have actually completed. If we check in the background, we can see that the tasks are still running. If we wait at least 60 seconds, these will disappear. We don't really have a correct view whether or not this has been successful, as the process was still running after the playbook finished. That being said, we can see that there is potential for speed improvements. So, let's look at this a bit further. We move into the next revision. We've previously covered the register option, so what we're doing here is registering the context from the asynchronous command, and we're showing this using the debug module. We're also showing it with Ginger 2 with the example at the bottom. And there's a good reason for this. Let's run the playbook. And I'm going to scroll up slightly. Okay, we've got some good context, but it varies depending on whether or not the job was executed or was skipped. You'll notice we have the started and finished keys for jobs that run. For ones that are skipped, we do not have this. We can still work with this variation, we'll just need to take it into consideration. You'll also notice that we have an Ansible _job _ID. The asynchronous module uses this as an input for gathering the status on a job. Lastly, if we scroll up to the previous output where we were using the debug module, you'll notice we have the dictionary key result1. When used in a Ginger 2 context, this is omitted with just the content. Moving on to the next revision. We're going to gather the job IDs. Even though the context varies, we can use Ginger 2 to work around this. If we take a look at the top of the playbook, we're specifying a variable of job IDs, which is an empty list. Then, at the bottom of the playbook, as we process the registered result of each task, we're looking to see if the Ansible job ID was defined. If it was, we're appending this to the existing list. Otherwise, we're just leaving the list as it is. In the last task, we're showing the job IDs. Let's give this a run. Okay, great. And if we scroll back up, you can actually see all of the job IDs. Let's go into revision 7. Now that we have the respective job IDs for each system for all background process IDs, what we're going to use is the asynchronous status module so that we can wait for all background jobs to complete. With this module, we're passing in the job IDs, registering the output in jobs_result, and we're waiting for jobs_result.finish. Lastly, we will retry this 30 times. Okay, so they've all executed, and now we're actually waiting. And if you recall, one of our tasks was actually set to wait for 30 seconds, so we can see that the others are completed. And we're just waiting on the remaining task. Excellent, that's completed. Moving to revision 8. Okay, and if we just compare this revision to the previous revision, you can see that we've actually removed the when statement, which was causing it to only actually execute each task against an individual host. When we run this time, it's now going to run against every host, and we'll put a timer on to actually see how it does. Okay, so now we've got a lot of jobs running in the background, and we're waiting for all of those jobs to complete. And we know that the maximum length of one of these jobs is going to be 30 seconds. And there we go. We were able to run the entire batch in 48 seconds. Quite a significant improvement from the first time that we actually tried this. We saw that this approach required us to use a lot of our Ansible knowledge that we've acquired in the previous sections. We had to use Ginger 2 scripting, register, until, with, and we had to use the asynchronous status module. That is, if you're using a newer version of Ansible, an approach which may be easier or at least beneficial, and this is looking into the different options that are available to the strategy that is being used to execute your playbook. By default, Ansible uses the linear strategy. This means all hosts will execute the same task before moving on to the next task. Let's take a look at a simplified version of our playbook. Step into revision 9. Again, if you recall, we have what is approximately 30 seconds of sleep within the playbook. Gather_facts has been disabled here to gain some time. Now, if we run this with time, we'll get a view of how long this takes to run. As we saw earlier, each task is taking more than 10 seconds. I sped this up for the purposes of the video, but you can see there that it's taken approximately 70 seconds to run. This is because, by default, Ansible uses the linear strategy. It will also use another default of 5 forks. We're running against 6 hosts, so essentially with the linear strategy, we'll be running the sleep command for 5 hosts for 5 seconds, then moving on to the other host for another 5 seconds. This gives the explanation of why we're waiting just over 10 seconds for each task, even though the sleep is only 5 seconds. We can tweak this, step into revision 10, and if you take a look at the Ansible config, you can see there we have the fork set to 6, and we have exactly the same playbook. I'm just going to run that again. Okay, and that brought that down to 38 seconds. Let's go into revision 11 and we're going to look at the serial nature of execution. In this revision, the playbook is called Serial Playbook. Here we're stating to run against 2 hosts at a time using the serial keyword. This approach is especially useful for performing rolling updates across a batch of systems. So for example, if we wanted to limit to batches of 2, we would use an example like this. So you can see we've got CentOS 1 and 2 as the first batch. Then we've got CentOS 3 and Ubuntu 1 as the second batch. And we've got Ubuntu 2 and Ubuntu 3 as the third batch. Excellent. Move into revision 12. We can specify serial as a list, allowing us to batch in incremental stages. If we run this, we'll see this in action. So in the first batch, we're executing against 1 host. Second batch, we're executing against 2. And third batch, we're executing against 3. Step into revision 13. If we're working with a large number of hosts, or our variance of hosts is likely to change, we can use percentages. If we try this out, those carefully crafted percentages give us the same result as the last time. Lastly, let's take a look at one of the newer strategies in Ansible known as free. This example is called Random Slow Playbook. And here, each task is going to randomly sleep for an amount of time up to 10 seconds. Let's run this. And I sped the video up here. You can see that we would have been waiting there for 55 seconds. Step into revision 15. And we've got a minor change there, just the inclusion of strategy is free. And what's going to happen when we run this? All of the tasks are going to be broken up and are going to be executed individually. So what we'll actually get is the correlation of speed from each of the tasks running in a free way. Let's run this and see how it plays out. This is actually a great one to see because you can see the individual tasks being run. we're no longer waiting for a task to finish before moving on to the next task. Okay, great. And that took that down to 42 seconds. Okay, so I hope you enjoyed this one and now have a better understanding of some of the performance aspects and how you can batch and serialize jobs. Please join me in the next video, Task Delegation.